Okay, there's a lot that I could talk about with this motor, so I want to keep it short and informative so people can learn as much as possible from my mistakes. Short bit of background on how this project came to be. I designed and built this motor originally in spring 2024, and I test fired it for the first time that summer. It went pretty alright, but I was pretty unhappy with two things. First, I really hated how long it took to get to full pressure. Comparing this motor to industry motors and even some amateur motors, the time from ignition to full pressurization was horrid. Second, there were serious discrepancies between the simulations of how this motor should have burned and how it actually performed. Since then, I've made some improvements. The second burn went well, as you can see. The major improvement was the pressurization and time to peak thrust. Addressing the two issues with the first motor, I fixed the time to thrust by changing a couple things. I first researched igniters and their effects on different geometries. I did a development campaign, a test campaign, and I found the best way to make igniters for KNSB motors was a high surface area, high burn temperature, and pressure buildup. This was achieved using a pyrogen I developed made out of ABS, magnesium, potassium nitrate, and a small amount of sulfur. This gets mixed with acetone and then cast onto a 3D printed form with high surface area, which allows it to burn very quickly. Pressure buildup in the motor was handled by a plug, which I printed out of TPU. Hot glue also worked for this on smaller motors, but the size of this motor was more conducive to a printed plug similar to a burst disc in large motors. Additionally, minimizing hard-to-get-to surface area in a motor's geometry significantly helped with improving the ignition, which I determined through doing a couple tests of different geometries like Bates and Moonburn. The second, more pressing issue was the discrepancies between simulation and real life. Unfortunately, I have not a great idea of what could have caused this problem beyond voids and cracking, because the grain did have a few and was a little bit cracked, but it didn't seem like it would cause any significant problems. I think that erosive burning could have caused it, but I'll have to do more testing to find out. Aside from these issues, there were a few other things I tried that worked and some that didn't. One, I cast with 3D printed ABS. This worked perfectly and didn't warp unlike PLA does when casting. 2, the liner I used was homemade out of paper and wood glue. It worked pretty well as a thermal liner, and the majority of damage it took seemed to be from after the burn, as the temperature on the case was still lower than from the first burn that the case endured. 3, I cast straight into the liner, which is probably why the void showed up, as it bonded very well to the paper on the inside, and I had to tamp quite a bit to make sure the clumps on the sides didn't prevent flow. The big problem with this burn were, as I mentioned, the quick burn, which the simulation didn't predict. I don't know what caused it to burn that quick. Voids, erosive burning, propellant mixing issues, but I don't have a good idea. That's about it. There was an issue with the pressure capping, but it was caused by my own wiring. I need to lower the voltage out of the transducer before reading it with the Arduino. More about this motor I could talk about. I just wanted to talk about this test specifically and to compare it to the first test of this motor. If you want to see me talk more about this, like the igniter formula or how I design grain geometries for burn curves I want, let me know and I'll do my best to create more and higher quality content as this. I just wanted to put info out there.